Okay, we are now live on YouTube. Over to you, Anustup. The virtual stage is all yours.
Yeah, thank you for the warm introduction. I guess my audio and video is properly visible and audible to everyone, right? So if you guys have any problem with my audio and all, it's, just feel free to ping up me on the chat section. Yeah. So thank you everyone for joining today's session. So today we'll be talking a lot about GPT-3, the power of the GPT engines, and the major point of today's talk will be, since the industry is talking a lot about GPT engines and they are just placing applications everywhere, wherever we can find a fit for it, or wherever the engine is giving some sort of good prompt or good sort of results to us, we are trying to fit it up. But there is an art of doing this kind of large language modeling or playing with this LLMs that is actually comes from the concept of prompt engineering. So that prompt engineering is already being designed a lot before this kind of launches of these GPT power engines. So it's coming from the previous concepts when on that days when we have OPT, GPT-2 or GPT-J and Neo X and something like this. So today I will be talking more about the prompt engineering, how to design GPT systems, and in which specific tasks or in which specific industry applications you will be able to harness the power of the GPT, right? And I will be also talking how it internally works and what are the best case applications, right? And then I will jump into Q&A. Yeah. So thank you for my introduction. So yeah, just can you just allow me to share my screen? I guess there is already a screen being shared. Just a second. So cool. I guess the screen is visible to everyone. Okay. So before jumping into the top, right now, because every day of our life is we are getting some kind of the news sort of the news buzz, right? GPT had done this, or right now the Chat GPT had launched. The Chat GPT is a newer version of the GPT-3 that contains of a GPT 3.5 Turbo, right? And the GPT had solved this paper. GPT can solve complex mathematical equations. GPT can generate text. GPT can write content. GPT is writing code for you. GPT is solving doubts for the student, and massive applications we can see from the side of the GPT-3. So what is a very basic concept of the GPT-3 comes from? It comes from a very trivial NLP task that we already call as the zero shot learning, right? So this is a modified version of that kind of a zero shot learners that is being rather improved with some layers of this NLP level modeling, that we change it to be a large language model. So when we speak about this large language models, we always need to understand these large language models are being trained on billions and billions of parameters, right? So when we speak about the latest version of the GPT-3, it has been trained on 375 plus billion parameters. And though the perfect count for GPT 3.5 is not yet released, but yeah, it started from being training from 175, 180 billion parameters. So it have exactly all over the data being present over the web, right? Still 2021, it had crawled all over that data that is being present on all angles, and it have the complete knowledge base of that particular data, and hence we called it as a large language models. So where the beauty of this kind of GPT-3 engine lies. So many of you might have, if anyone of you is coming from specific NLP domains or have worked on some kind of NLP engines, many of you might have this question like, okay, why GPT-3 is so much beautiful in generating the tasks, or so much beautiful to generate any task, or why is it so robust? We have attention architectures beforehand, we had transformer architectures beforehand. In trivial days, we have RNN and a top of layer models which was being built on RNN. So what things that they cannot build and what things that GPT-3 had built on, right? So this is a common question that is being raised in the industry. So one of the major problem for this kind of NLP tasks is the context length. So suppose for an example, just suppose understand from a very layman's point of view, when we are doing any kind of a conversation, so suppose two humans are simple talking with each other, right? So they are just telling multiple types or multiple length of the sentences. The length of sentences might be short, might be very long, or it might be a complete might be a complete assertive sentence, or might be a convincing sentence that have multiple paragraphs or something like this. So whenever a human brain listens this kind of sentence, it processes it based on the information that is being present as well as the information that is being already have within a human brain, right? So it have the complete context to it. But when we come to the NLP task, or when we tell it to for an AI engine, decoding or extracting the exact information from a very large contexted lines was a difficult game for on that time when we called it to be a RNN to decode a complete a long length conversation or a long length sentence. It was a very difficult game on that time. So on the top of that, we introduced several kind of mechanisms. We introduced LSTMs, we introduced sequential learners, we introduced layers for transformers, we did feature selections by help of an attention engines. So what was the problem is what we call as a knowledge base. If you just go to the trivial paradigm of this NLP architectures that we call as the graphical learning, or when we speak about the graphical neural nets, though plays a very important role for the robust scale NLP engines. When we speak about zero-shot learners as well, if you are dealing with any kind of entanglement problem or simple text classifications, you can use easily the zero-shot learners and fit into any kind of production environment. So how does these things play in the backend? They have a complete graphical architecture that actually plays. Okay, you have a long length or long contexted sentence. As that particular sentence might point to multiple knowledge bases. For an example, just take just for an example, if I am telling someone, okay, so please write a code in C++ about finding even numbers in a list, and here is the given list, and you have to write most optimized solution for it. So this particular sentence is obviously a very long length sentence, and it is pointing towards multiple knowledge bases. So what are the knowledge bases? It first points towards the domain of the code, the domain of the language being the C++. What kind of operation the code have to do, finding an even number in a list, right? Also, the list is provided, means the input is a domain, operation is a domain, language is a domain, and also what type of action the person have to perform is the most optimized solution in the code, right? So this is even a domain. So when a multiple domain plays within a single lines, this trivial engines gets confused in shifting from one domain to another domain. So again, the data shifting or feature shifting being a lot of problems, because when you have two features closely cross-related with each other, or two features, just imagine a graph, imagine a very parabolic graph in simple mathematics, and you have two ends of the parabola, and just understand their Euclidean distances are very less, but yes, they are having some sort of unique features in between them or some sort of unique parameters in between them. That's why they are being placed at different positions, right? So there are several distance metrics being already being introduced to understand positions on a plane. When we can't able to play with a 2D plane for a feature architecture, we shift to the 3D architectures that comes from the spherical distance measuring or any kind of XYZ. I'm not going into that kind of deeper mathematics, but yes, there are two features being present in a parabola, and their Euclidean distance is less, but their position is different. Thinking position as a parameter, we understand these two features to be a very unique feature, right? But there might obviously these two are the positions are different, so obviously they are the two unique features, and they have some sort of difference in between them. So these trivial architectures have a fallacy of understanding what is the difference. So here comes the beauty of the GPT-3 powers. So one of the common beauty why the GPT-3 is playing in this game, or can easily can play in this game, because it have a large DB of all kind of features being present inside it. So that is a very common layman way to address this question. Another is it has a very robust knowledge base. So why a robust knowledge base being spoken here is all about. So GPT-3, the process of training a GPT-3 engine is not something a trivial process of training. It is something coming from the reinforcement learning or human interfered reinforcement learning that we call as RHFL in NLP terms. So basically, there is always a human interface. So just a very common example I used to quote, like generally. So suppose one fine day you are just playing with ChatGPT and you just ask a very insane question to ChatGPT. Or for an example, you ask ChatGPT, just print the value of 2 plus 2 equal to 4. Just you ask ChatGPT to print the value of 2 plus 2, and obviously it answered correctly 4. Now you want to trick it with it, right? You tell like, no, 2 plus 2 is equal to 5, and for my case, it is always 5. So you will see after some time or after some sort of minutes, it will keep you generating, okay, 2 plus 2 equal to 5. 2 plus 2 equal to 5, or any value you give, it will be start generating for it, right? So that is the beauty of RHFL. So RHFL always learns from the human feedbacks or the human annotated levels, right? So entire knowledge base, whatever on which the GPT-3 is being trained, is being properly leveled and properly segmented into several knowledge domains. So if anyone has the idea of the knowledge graphs, so this knowledge graphs always plays in this case. So that anywhere when we just go for the KGs, so when we speak about a KG, a knowledge graph is nothing but a graphical architecture which is having the multiple domains inside it, and every domain is either cross-related with each other. Like all nodes are either interconnected with each other, and they either follows a direction, and it's not always that it needs to follow a direction. It might be a cyclic graph, it might be a DHE, it might be something like this, but there should be an interrelationship in between the nodes, right? So in the same way, following the same architecture, the GPT-3 domains are being, or the entire knowledge base that is being designed on the entire data crawl data up to 2021. The data is being annotated in such a manner, if at a certain point of step, if a sentence is coming and in that particular sentence, there are multiple domains being pointed, all that domains will be properly mapped, as well their interrelationship will be calculated, and based on it, a response will be generated, right? So now here comes a very common question, like, so this is all about a very high level overview of any architecture, of how it is being designed from very architecture point of view. But again, what is the basic game of a GPT-3 engines? The basic game, I will be coming to the Q&A at the end of the session. So if you guys want to ask any question, or you guys can just post in the chat section. So it will be handy for me, right? Okay. So let us come to the next part, right? So when we speak about this large language model, so again, what are these LLMs actually? These LLMs are nothing but a text generator engine. So these are all the subparts of the generator architecture or generative architectures. So now let us just take a step back about these generative models. So when we speak about these generative models, it have the power to gain some context, and based on that context, it runs some sort of computation to have a high level inference of that context, and then it writes according to it. So this is a very high level overview of any kind of generative architecture. So though industry have seen many generative models till date, it's not only GPT-3. Previous of the GPT-3 or previous the onset of the Dolly, we have seen several GAN engines, right? So the GANs are also on the same game of the generative engines. Or previously the industry have seen Facebook OPT, so they are also coming on this kind of LLMs, right? So this is not a very new game. In industry, this has been present for last 20 years or the 15 years. People are researching, launching a model, and just they are playing with it. Just for your kind of information, like right now we used to speak for Dolly, right? So basically, who is the founder of the Dolly, or the person who wrote the algorithm for the Dolly, is already just doing the same sort of work for last 15 years. His first launch product was crayon.com. Even if you search in the Google, you can find the website. It is still alive, right? So it exactly do the same text, exactly do the same thing what the Dolly used to do, but on a very lower level of accuracy. So whenever we speak about the generative architectures, so generative architectures are two types of several broad heads inside it. So when we call it to be a heads of an architecture, it is something like, one is the again, like it comes from a basic attention architecture of an encoder and a decoder mechanism, but here encoder and decoder plays both in the cases. One is for the generative, another is for the delimitators, right? It have the two specific heads inside the architecture. So what happens if you just understand it to be the two heads? One head generates context, another head try to infer out of the context to print something. So that is an important thing. So there are again two things. One head is already pre-trained. You cannot get insight to that kind of architecture, or that is already a pre-trained architecture. If you tomorrow you want to say, right now OpenAI had launched its open APIs. So in that APIs, it openly claims like, okay, you can fine tune a GPT-3 engine. So it always still fine tune a GPT-3 engine, not completely train an engine. So basically, since it is an LLM, it has two heads. So one head is the internal architecture that generates the context. Another head is inference engine. So always when we fine tune a GPT model, we always fine tune that inference engine. That is the head number 2, right? So in that head number 2, you can just play with any kind of prompt. You can feed your own kind of data, own kind of the level data, but in the bulk as well, because it is already having 375 plus billion parameters being trained on exactly. Right? So So this is a very basic idea about GPT-3 or the architectures of the GPT-3. So now let us understand before coming or before jumping into these GPT-3 models or discussing more about it. So let us understand what was the beauty of the text generation models, because GPT-3 is primarily something that generates something for you, right? So previously, this text generator has been present still from the onset of the birds, right? So many of you might have a question like, okay, if there is already been present on the bird, so why we are not using BERT right now? Or what is the use case of BERT with respect to the GPT-3? Is it already being present inside architecture and something like this? And if BERT can already do that, what is the extent of it? Or why cannot we do that with an RNN? So whenever we speak about any kind of generative model, so you can always when you are giving a prompt to ChatGPT, just for an example, it always tells you about can you take a simple text message and show the BERT works? Yeah, I will do it. I will obviously do that. Yeah. So just let me end my talk, and then I will obviously come to your one-on-one Q&As. Yeah. Yes. Cool. So let us come to the okay. So when we speak about that kind of the BERT architectures, so yes, the birds being already trained on a huge amount of knowledge basis, and they can easily generate context or some kind of the vector relationships where when we pass any kind of the models, there are multiple types or multiple ways of generating embedding inside them, and they as well generates interrelationship in between that kind of embeddings, right? So based on that, we can generate or we can execute some sort of tasks when we speak about the birds, right? But again, there is a limitations for that kind of the text generation engines being found. So just for an example, if you are playing for the chat GPT, so when you are speaking of the chat GPT, you suppose you are passing a very long context or passing a very long text. So it always speaks or always tells, okay, amount of the prompt, the length of the prompt, or the length of the tokens is exceeded. I can take this much token, and apart from this, I cannot. So every large language model that is being created till date can generate context from a certain amount of token, because even that kind of transformer architecture is being trained in that token limit. So internal pre-trained architecture cannot work beyond that, right? So yes, they can increase it. They just keep it fine-tuning and pre-training and pre-training. That is their internal use case. Though for the free plans, they generate some sort of tokens and they can increase it at a certain amount of a quota if someone requests it. But yeah, that amount of the quota for the tokens is always being generated. So what is the general limitation of this kind of engines is you have to provide entire context within that certain token limit, or if your context is not being present, then it have no available resource or no possible measure to directly get access to the extra token powers or just get into other sites or generally infer it out from the provided token. So this is the common way of the tokenizing the models or how the internal token structures work. The first thing. The second thing is when we speak about this kind of text generation engines, a text generation engines is again based on our very basic level NLP tasks, right? So whenever we generate whenever we execute any task in NLP, so what we do, we have the data, we understand how sequentially suppose you are doing a simple text classification, right? So for the common text you can do, you will look on your tokens, you will look on your sequential architectures, right? Or how the sentences is being, or suppose you're playing on utterances, how your utterances is being specifically designed and how they are interlinked with each other. Based on it, you have a choice of embedding, what kind of embedding you should generate. And then based on an embedding, if it works for you, you will generally call for an embedding for a simple detector model, or you can choose what kind of architecture you want to play. You can just post or play. Right. So again, like it is completely based on what kind of relations being present on that particular data, or every vector have their internal relationship, right? So when we speak about the GPT-3 engines, this entire concept lies as well same, because from a very basic point of view or from a basic architectural point of view, the GPT-3 equally follows any kind of transformer architecture. Even we use bird head attention modeling architectures inside the GPT-3 model, right? But it is having the power to generate context from a large amount of the text or a large amount of the data. So that is a very big beauty for it. So So what things the GPT-3 had solved for us? Yeah, just a second. Okay. So, okay, cool. So industry had is being fine tuning this kind of GPT-3 architectures from last 10 years, right? 10 or 15 years. So on a very trivial days, people had trained with GPT-J and GPT-Neo X, and then there was an onset of general GPT, and then it was GPT-2, and now we are having in an era of GPT-3, right? So, so in this specific onset, what things they had specifically fixed up. So they had fixed up distributional stats or any kind of the feature distributions in that particular data. So if you just go to a trivial architecture of a GPT-J engine, so in that GPT-J, it already have some sort of 120 or 110 billion parameters. But where it was specifically failing, when you are just hitting that particular engine for a specific task, okay, this is a set of thing and you have to summarize it, it can easily do it. But when you are playing with some sort of prompt engineering, means like you are playing with the multiple prompts, or you are giving a complex text form, or you are giving some sort of text which is having a lot of variations inside it. Okay, there is another question: GPT-2 versus GPT-3. What is the difference in terms of machine learning? Okay, nice question. So, okay, I will be addressing all your questions, Ashwin, right? Yeah, I will be addressing all your questions. Yeah. So, okay, so what was the discrepancy being present on it? Like, is the distribution, right? So, when we train any kind of a model, so feature distribution might be proper so that the model can behave properly, right? So when you are playing with a very large database of the features, just for an example, you have a huge features or 10 billion features, 20 billion features like this. So there is a common fallacy of playing these features. These features always comes into a hyperbolic curve, right? So what we call as a hyperbolic curve of the feature learning in the terms of artificial intelligence is something like the feature is initially performing nice, and when it is going deeper and deeper of a neural network layers, it can't able to distribute itself, or it can't able to distinguish itself from another feature levels, right? So it generates a hyperbolic drop, and finally the model gets into nothing. So this was the common problem of any kind of GPT-J as well as the GPT-Neo X. So what they fixed the distribution architectures. They introduced complete KB, the knowledge bases. The knowledge bases are again the modified version of that kind of knowledge graphs, right? And then they parsed it off, and then they launched completely as a GPT-3, right? So all over mechanisms that is being done in an improvement state is to understand the context as well as to understand how you can specifically fit your prompt to an internal architecture that is being present, and so that you can extract some out of it, right? So now many of you might have like tested GPT-3, right? So in a GPT-3, you can easily do any sort of machine learning task or any sort of NLP task. For an example, there is a common trivial NLP task in our days, right? It is called named entity recognition, NER, right? So what does an NER do? Just for an example, there is a sentence called a human. I am graduated in a year of 2019, and I am presently doing a job at Google. So if this is a sentence, right? So what does this NER used to do? The NER specifically tags the individual keyword based on their domain. So just for an example, year is being tagged as year, as well as domain of work can be tagged as domain of work, or even it have the specific segments of organization. So it has an organization name as Google, the Google being tagged as an organization. So again, these NERs also behave on a very same level of architecture. Like it is having a pre-trained knowledge base of that entire thing. So whenever it finds anything similar utterance or anything similar word to that, it tries to match. So it tries to match that particular word with the entire thing that is being present on a KB for a specific organization. And then if it found the match to be amount of a certain threshold or a certain variation, okay, it prints it. Okay, this can be an organization. So several tasks we used to do in our day. I had to do life using that kind of information extractions. We use spacey NERs. Even the spacey NERs help us right now with the transformer architectures, and many things we have improved on it. Right. So this thing you can easily do by the GPT-3. So just not speaking from the NER. Another famous task for NLP that we call as the question answering. Right. So what does this question answering? So in this question answering, there is a huge answer of the dependency parsing. So what does the dependency parsing do from a very underlying NLP architectures, or for your knowledge for a dependency parsing. So just for an example, if I tell something sentence like this, okay, I am 21 years old and within this amount of time, I am paying this much of EMI by earning this much, right? So just for an example, I'm 20 years of old, I am paying 20,000 of the EMI by earning 80,000 a month. Just for an example, if you uh, oh, okay. So just this is a particular sentence, right? So simple dependency learning of or dependency parsing this particular sentence, but it will point okay. So your age is dependent with the amount of EMI you pay, and that amount of EMI you pay is completely dependent on your earning, right? So it generates an interrelationship in between it. So how it generates? It generates based on information being present, or it may do some sort of parts of speech tagging, POS tagging, because if you just go to a trivial grammar of English, so we always play with that kind of thing, subject verb agreement, how the subject is related to predicate, how inside the predicate the verb and the nouns are itself related with each other. That is the same concept with each other, right? So dependency parsing have a direct application in a field of NLP that is called as question answering. Right? These are very trivial tasks. So when we speak about question answering, so what you do is basically you pass a context, you have a paragraph or you have a passage, right? And you just asking a question to the model. Hey, so if the passage is telling about some event, right? So you might ask about this kind of question: when does this event happen? Who the people had joined in this particular event? Who what happened in this particular event. So what it will do, it will try to find actual context, or not the context, actual dependency parsings present on your particular sentence. So every utterance have a dependency parsing. So if I am just asking when does the event happen? So does is directly parsed with happen. So it is onset, right? So date is directly parsed with the onset. Onset means when does this happen? This is the specific question. So it will try to find that date in the entire passage being present. So this was the general architecture. So GPT-3 has also power to do this kind of things, because these there are several other NLP tasks. I'm not going to very deeper of that, but yeah, this all kind of tasks are very easy to crack, because these are nothing but you can easily crack as well by simple development. You know no need to write an entire NLP. You can do a simple keyword search and find it out. So these are very low hanging stuffs that are the very fundamental levels of a GPT-3 engine. So if you think, how does a GPT-3 extracts an information, or how does a GPT-3 writes for you, right? So at the very back end, or a very trivial level of the mechanism, it is doing some sort of dependency parsing, right? Because without dependency parsing, it even cannot have the context of the line. So now you might tell what kind of dependency parsing and how the trivial dependency parsing is being outperformed here. So yes, there is a modification in the layers by adding layers and layers of machine learning over it. We have introduced attention mechanisms. We had introduced LM heads that are called as the large language model heads. That large language model heads itself have a specific power of information or specific context of an information. So while doing the dependency parsing, it is already aware, okay, I am doing dependency parsing for this specific task. And these are the things I have to remember for doing this sort of dependency parsing. This is another beauty. Another thing is called self-masked attention. That is being the unique point of any kind of GPT architecture. So the beauty of this kind of self-masked attention is, so if we are passing any line, it can't able to get the specific context of that particular line. It will generate all types of its variation, and that is being present on the knowledge base, and it will try to infer something out of it, and it will write something for you, right? And several other being applications or innovations being made on an architecture point of view. So, okay, cool. So this is all from the architecture point of view of the GPT-3. So I guess we have some sort of idea how about GPT-3 works on an internal. So now let's come on the application part first. How the industry has been using GPT-3, and how you can use GPT-3 if you want to launch your business, or if you are even a machine learning engineer or a data scientist, or if you're a developer, right? So just coming from a very top level, we have fancy examples right now, like GitHub Copilot is again an example of GPT-3. You can test out Replit code editor, right? It's even completely based on a GPT-3 engines, right? And you can test about many other things XYZ being launched right now. Even ChatGPT is another very big example people are using. So, but from a very basic point of view, every text generator has some sort of limitation. So first, let's look on the applications first, and then we will come on the limitations. So the first thing is, the biggest example that we had found in a GPT-3 is the content industry, right? So in the content industry, GPT-3 has really did an amazing job. It can write poem for you. It can write any kind of blogs for you. It can write any kind of text, any kind of emails, any kind of messages, or it can even talk with you, understanding your context, right? So content industry or copywriting or correcting an English or specifically structuring a document, paraphrasing a document, summarizing a document, these things are massive applications of the GPT-3 right now being present. So now here comes the thing. So just for a specific use case, just I'm picking one use case like blog writing. So how does this text generators write? So just for an example, you go to the GPT-3 and you just give a prompt like, I want to write a technical blog on Java, just for an example, or Java, or just be specific. I want to write a very technical blog on k-nearest neighbors, their limitation, and how does the k-nearest neighbor works, right? So this is a very machine learning blog. What does this GPT-3 will do? It will simply take the prompt to the backend and it will search all available blogs. It is already having that data because it is being crawled data. It is being trained on a crawl data up to 2021. So it is being looked on the all sorts of data, and then it will try to find some sort of interrelationship in between the documents. So it is again coming from a very low level NLP task, a very low hanging NLP task that is called document parsing. So entire document or entire conversation that we do, like any conversation is full of sentences, and every sentences is linked with each other. That linking is actually pointing to a domain, and that domain is the information or key to your information. So that same parsing is being done. Giving a prompt, that prompt is taken to the backend. It is searching for all possible sets. Within that set, some relationship is generated. Based on that particular relationship, they are being pointed to a domain, and that particular domain is rather calculated and rather passed to a writer engine, and it then takes the context. Okay, this is the domain, these are the available sets. Now what I will do is I will either paraphrase the content or either I will be adding some sort of extra line in that content. Any of you might have the question, adding extra line might be an amazing beauty. No. So this is also coming from a pre-existing NLP task that is called fill mask task or mask filling task, right? So just for an example, mask filling is something like this. So just go back to your Googling days, right? Just go back to 2015, just go back to 2017, something like this. Like, so basically what happens, you are going to Google search and you are typing top. So it gives you a prompt, top images of the day, top weather conditions of the day, something like this. Suppose you have written something and you missed a word. So Google automatically gives, did you want to mean? And it just add the word inside that particular sentence. So that is called as a mask filling task. So again, mask filling task is based on complete embedding matching. Any prompt is coming, is tried to match with the pre-existing embedding, because whatever sentence we tell, the basic level checking for any sentence is a grammatical mistake, right? So Stanford people, like, you can find enough amount of an open source model from Stanford NERs or Stanford LMs. Like they had a huge DB of the English grammar, which is being specifically used for grammatical corrections in an English, and generally the industry use it up, right? So mask filling is another type of the thing. So they generally paraphrase the sentence, they fill the mask inside the sentence by taking the context from other documents, and it just force it up and write a blog for you, just for an example. Now, here you want to generate some sort of variations, right? So what sort of variations you want to generate? So for the first prompt, you are told write a technical blog on k-nearest neighbor, its limitations and its use cases. So now just add or just feed a new use case. So just for an example, you feed it, write a blog for k-nearest neighbor, and the k-nearest neighbor, I am applying a k-nearest neighbor on this data. I'm applying a k-nearest neighbor on any data, and it is a COVID data. And that COVID data is specifically for Bangalore, and I want to predict something out of it, and now write a blog for it. So you have defined your own case scenario. So just for an example, this is a very unique case. So just for an example, just for a time being, forget COVID had not been present inside the India, and before 2021 there was no COVID. The COVID started from 2022 itself, right? So, and from 2022, you are just putting this entire thing like I want to fit KNN into the COVID condition, and write a blog for me, right? From blog, from code, everything you write. So if that data is not pre-existing on that GPT-3 model, so here these guys played with something called as the zero-one user engineering. So what is zero-one user engineering? If you can't show user the best probability or the best match results, right? So just show them some sort of the nearest results or something called as the matching results. So this is a beauty to deal with. Say, whenever we call AI engines in production, like just coming, so speaking from a history of AI. So history of the AI have seen, like AI have already shown colors from it for many times in an industry. So just for an example, if you just remember the days when BERT was launched, on that time the BERT was doing amazing stuff. It was the onset or the very beauty of the zero shot learning. The people can call the BERT, people can search, people can classify the text by directly writing. People were started doing spam analysis in their calls, in their messages. People were doing eliminating emails, simple the text tagging. Every kind of the works was getting automated. But again, the industry got a fall because these models every time cannot be launched into production. So what is the beauty of any kind of AI engine that is being actually greatly handled by GPT-3 is whenever you want to launch any kind of AI engine, there is always a FN case, false negative case. So if your model cannot detail or model cannot entail that kind of the negative case, then what you should show to the user, right? So there should be something that is very similar or in a very sophisticated way. So this is not a correct thing, but this is similar thing I can generate for you. So what it will do, I'm just telling, if you just giving this kind of prompt, hypothesis is the COVID has not yet onset. The COVID is onsetting from 2022 and you're asking GPT-3, though it is not having the data, it will try to write some sort of story for you. What it will do, it will write the entire thing for KNN and it will try to fit. Okay, so this is the KNN model, imaginary data set for something you have mentioned, COVID-19 is something like this. If you feed the model, your expected code might be this and something like this. So here, again, they had played a very big game for embedding matching. So what does this happen? If it finds any new word, so it just ignores that particular new word for some time and it try to match, okay, what is the user is asking of. The user is writing you to write a code for KNN on a data that data might be named as COVID. So this is again a basic level task. So it is already having data for that basic level task. So it downstream your task into a very basic level of text chunk, and based on that particular text chunk, it is generating results for you. So that is again a very big game for contextual AI ML. But yes, again, it is a very big threat if the data being not present for the GPT-3 engine. What's next? So just before coming, this is one of the limitation if the data is not present. So hence the data is not present. So just keeping aside this content industry, just keeping aside, just content industry, I want to mean like not any kind of educational content, because when it writes the educational content, it might miss some sort of context because it is already writing from pre-existing sources. So basically, if you want to specify, just for an example, you want to teach artificial intelligence to class 7 student, and if you are using a GPT-3 blog, it will write everything from you from 1950s to from 2021, right? It will write everything for you. So that is not an appropriate content. Difficulty level tagging is again a very big game that is being not cracked by GPT-3, right? This was one of the limitations, right? So now come to the next industry. So in fintech, people is still trying to integrate GPT-3. People is trying to integrate the power of GPT engines for forecasting or trade forecasts, as well as giving the real-time prompts to the user that, okay, you are playing a wrong game, man. Just invest in this stock at this particular moment, you will get this much of return and something like this. So again, here the GPT-3 loses the game because the GPT openly claims we don't crawl the real-time data. We learn from a real-time data. Just for an example, if you are prompting with us, if you are chatting with us at that particular time, if I am generating something and if the user raises, your output is not correct, immediately we logs the data, that data gets manually leveled or any kind of leveled with some sort of mechanism, and a model get itself trained at the backend and it get advanced at every point of time. But it doesn't learn from a new data. The crawling is not happening. Crawling is not happening real time. But for the trading industry, but for the stock industry, you have to understand every point signals, like how it is being changing at all amount of the points. So we have not seen a very large, massive scale applications in that particular fintech industry. People are still trying to explore, but the real time game is still yet uncracked. This is the second limitation. Now coming to the third part of it. So what? So if you come to this type of industry, where we call as an edtechs or medical techs, or specifically speaking about edtechs, yes, in the edtech it has given a massive application because it can write the code. It can write. It can assist you by commenting the code. It can understand what kind of error you are generating while writing a code. But this is again, remember, when you are playing with any kind of GPT engines, so every GPT engine have a probability threshold. So just if you read the GPT-3 Hugging Face docs, so where OpenAI had publicized all of their models from GPT-J, from GPT Neo X to GPT-3, everything, not the appropriate version of GPT-3, but just very lightweight version of GPT-3. So every GPT-3 prompt or every GPT-3 output have something called as a probability threshold. Above that particular or below that particular probability threshold, the GPT-3 marks flagged out. Flagged output means it is being internally flagged that I am not very sure about this output, but still showing to the user because I found it to be a perfect match. So what that people used to do, if you just calling the entire GPT-3 architecture, you can have that access of that particular flagged output. So what people write a layer of machine learning, people create another layer of bot transformer or another layer of flank T5 transformer, any kind of T5 transformer you can train on it so that a flagged output comes, and whenever a flagged output comes, it is being raised, whether it is correct or not. You can either write a code or you can manually level it up, manually correct it up, and just fine tune that model so that it adds an extra level of the security to it. So his particular game is being cracked by Replit. You can find Replit Ghostwriter. So Replit Ghostwriter is amazing application of this kind of wrappers over the GPT-3, right? And even they had cracked amazingly the prompt engineering in that particular GPT-3 because they gives the prompt at all operational levels. But yeah, in edtech, it has seen a massive outputs. The people is using GPT-3 for doubt solving. People is using GPT-3 for writing their codes, solving their assignments. But yes, again, since most of the thing when we speak about the education domain is coming from a previous context, it already have the context to that, so it can easily solve it up. It can easily write for it. So apart from this, the GPT engines can be used for real-time conversations. So even we the people used to do for conversation engines for building high-powered chatbots because it learns from the conversation itself. So the biggest term that GPT-3 had called itself is called as in context learning. That means when you are conversating with that particular bot or conversating with that particular AI, since it is coming from a background of reinforcement learning, so it is learning in that particular conversation what is your intent, what is your way of talking, what are the general patterns of talking. This all kind of things are getting analyzed. So a massive application is being seen on several types of chatbots, several kind of communication engines, calling engines. People are integrating it directly and getting amazing results. So now let's sum up with the limitations and how or where to use GPT-3. So again, complete dependency on the GPT-3 is not the correct one because these text generators can be best writers and can be a bullshit writer as well, right? If it have the context, if it have the knowledge base, it will be a best writer. If it doesn't have, you have to struggle to make it best, right? So this is a very common thing. Second thing, in industry, the GPT-3 have amazing application if you are using to fasten up your jobs. Even the people, yeah. So even the people like we, the machine learning engineers, or even the people who are the NLP engineers, right? They are cutting off the efforts in doing the tedious job. Just I'm telling, in a day-to-day life, since I had worked for more than 5 years in computer vision as well as in NLP. I'm telling in the trivial days what happens. Okay, now there is a text. Now label the text, generating variations for that text. Because if I want to create a suppose globe embedding, right? Suppose I want to create a globe embedding. Suppose I have a very trivial case, right? For an example, a lecture is happening, and in that particular lecture, an instructor is telling a student, hey, you understood it, hey, all okay, hey, is my explanation is good. This all kind of the nudging line. So I want to tomorrow I want to generate a model that will detect how much time the instructor had nudged. Simple example or simple application is okay, generate an embedding That embedding will have all kind of the relational vectors of this kind of the nudging line and just train a layer of BERT on it, just as a text classification engine, and that's it done. But for generating that particular globe embedding, what I have to do, I have to generate all sorts of variations, right? I have to generate all sorts of variations. I have to understand all kind of the tokens it can form. I have to see all kind of token variations, vector formations inside that particular embedding. So these are the very tedious jobs that comes generally in the day-to-day life of an NLP engineer or for any machine learning engineer. Leveling of a data, when you have a 10,000 data set, and you don't have any team of annotators who are working in a startup, and you are supposed to annotate that 10,000 data, it's quite an impossible job. So this kind of things is easily fastened up by GPT-3. You can use GPT-2 tokenizer. So basically GPT-3 also use GPT-2 tokenizer to tokenize any kind of sentence that you are being passed. So if you use GPT-3 for leveling a text, if you are using GPT-3, amazingly solved. And they had just overcracked any kind of the SOTA in it, right? Because it had already context of a very big knowledge base. So summarizing is amazing. So if you're using for summarizing, if you're using for tokenization, if you're using for lemmatization or very basic level of an NLP task, or just for an example for any kind of information extraction for tomorrow, if you want to build an information extraction model for your company, right? So just for an example, that spacey NER thing, they even have a lot of limitations. So if you guys, just for an example, you have an utterance. My EMI is 5,000 rupees a month, right? So this utterance in the real life, in the real case scenario, this utterance can be at many times. Suppose there is a Hindi conversation. So what will be the translated text? My EMI is 5,000. Sometimes it is not even an EMI. Sometimes my EMI is 5,000 in text. Sometimes my EMI is 15 number and rest in 1,000 is in text, right? So this is a common case. So when you just feed this thing to a spacey transformer model or any kind of spacey NER models, it will fail. So you have to fine tune their internal architecture. For fine tuning internal architecture that is being already trained on 1,000 billion parameters, what you have to do, you have to take an enough big data set. So where from you can generate, just go and hit GPT-3. You will get the entire data dumped within some minutes, and that's it. And you can feed and train easily that particular model. So here is the case. The GPT-3 plays an amazing role. Secondly, whenever you're encountering that kind of task, just for an example, if you are working in a controlled environment where you can have the context, actual context of any task that you want to get it done by GPT-3. Just for an example, summarizing your lectures. Or suppose you are running a website, and in the particular website, you know all patterns of an user interaction the user do in your particular website, right? So you do all, you know, all kind of the search the user can do, all kind of an operations the user can do. You have entire context, and now the user is stuck in somewhere. What you can do, you can just give an immediate prompt to the user. Hey, you are stuck in this way. I guess based on your previous operations, you might be looking for this particular thing. You can use that thing for a recommendation engine, but that is again for a entire controlled case, right? But it works amazing if you have the entire context. If you can have the context, then you can use GPT-3 for your controlled use cases. It might be question generation. It might be writing something. It might be prompting someone. It might be solving doubts. But if you only and only if you have the context of the previous thing, so that the GPT engine is a little bit fine-tuned, a little bit sophisticated, right? So, and the third or the most important thing that the people are fitting the GPT-3 into the multiple use cases, or even the people are being flying off by playing with the text or like writing code. GPT-3 is amazingly a great search engine, right? So basically, whatever the previous level search engines the industry have seen, it's amazing. It's amazing again. Like starting from Ngramming to Smith to Bird to the bird variations, Robert, Albert, D-Bird, Distilbert, and many XYZ variations of the bird. Then coming to GPT-powered engines, modifying, applying AI to Elasticsearch DBs, OpenSearchNet. Innovations has been done. When GPT-3 cracked is, they cracked in first in fitting the entire knowledge base, second, generating probability based outputs, third, GPT-3 can generate context from inter-domains, right? So basically, you can use GPT for an amazing search. So just for an example, you cannot find anything from Google, right? So because while Googling, you have to visit all kind of the pages and one by one, and then you have to see whether it is contexted for you or not. So just go and prompt in a GPT-3. So I want to do this task, any kind of data, because GPT-3 will give you a complete summary of all available solutions. Now, taking that particular solutions, you can go and write and do anything, right? This is an amazing beauty of GPT, but again, there is a very lot amount of the false cases being found. I'm just giving you a statistical data. At our company, even we are using GPT in many places. We are using GPT for doubt solving, for summarization, for user prompting, user log analysis, and many other places. But we manually analyze the data. Even I'm speaking from statistical data of Stack Overflow. So GPT got outperformed even for more than 65 to 70% of the cases because they were mostly personalized out. I'm telling from one of my personal experimentations with GPTs. So it was in class. I was applying GPT power to in class doubt solving. So when the people, I was passing the entire context as well as the context of conversation, transcript to it. The questions which is being predefined. Just for an example, what is the syntax? What is this operation in C++? So everyone knows it. It can have the data. It can have the access of the data. It have the access of the context. It is printing. But when there is any kind of contextual doubt or user-specific doubt, I cannot understand this particular syntax. Even having the context, the GPT fails to give an output because it is not that level user-specific. It is not having that level of contextual information. So here, generally, what we do, we used to write layers of machine learning on it to outstand the performance of GPT-3. We specifically chunked the data, we specifically labeled the data by using trivial NLP tasks. By using trivial NLP tasks, it might be entailment, it might be zero-shot layers, it might be few-shot learners, one-shot learners, and something like this. So that the context is getting passed to GPT-3 in a very modified way. And last but not the least, if you are building something on GPT-3, explore amazingly the prompt engineering. The more you play with the prompts with the GPT models, it will have more access to your ideology. That's it. Cool. So I guess we are having 5 minutes. So let's come to the questionnaire. Yeah, I will. Okay, you want to see live examples? Sure, I will be giving. So let's just address the first. How can we use GPT-3 to create a chatbot focusing on specific domain and purpose? Right? And what are the challenges for doing it, and what kind of resource needed for that? Okay, so basically, see, GPT. So again, like what kind of domain you are targeting to hit? So I guess you will not be hitting any kind of domain like which is not being set as an industrial standard. So just for an example, financial or education and something like this. Okay. So just I'm taking to be a very large scale or universal domain. If you're playing any kind of universal domain, so the GPT itself, just go and integrate that OpenAI API in the GPT will work, right? And then understand where it can't able to communicate. There do that 0-1 engineering. So now your question is then specifically focused on a specific thing. So I'm just answering for that. So just for an example, your specific domain is X, right? So if your specific domain is X, so since it is specific and you are the domain owner, you already have that kind of the domain knowledge, right? So how that this prompt engineering works? So this entire game of prompt engineering and LLM works based on a domain knowledge, right? So you are the owner of the domain since it is specific to you and you have the domain knowledge. So since you have the domain knowledge, you have level data. So now you had asked for the resources. Just for an example, you are a startup and you have no power to build that leveling. So that leveling, just suppose you have 10,000, 20,000 data points, go and hit ChatGPT. It will generate levels for you. Now that levels might not be appropriate in any other cases. Just one, you are done with generating in bulk, go and manually QC it. Now you have a set of level data. So now what is the best way? Now if you ask me, you have a 10,000 data points, and since it is a very minimum count to fine tune a GPT-3 model, you can go OpenAI V1 completions, that is the documentation page. In that you can hit that GPT-3 API, though they charge for fine tuning a GPT-3 model, right? Fine tuning a GPT-3 model, and there is an endpoint you can directly pass to their data. Even there is a data parsers being written on there, and then they just take the data in a JSON-ML format, and you can fine tune that GPT-3, and you can generate a model endpoint, and you can call it. Now, what from resources? From resources, obviously, you need a subscription plan of that OpenAI for doing this. Secondly, you need to have a very good computation system because training these large language models need at least platinum level of a GPU. Like it needs a lot of GPU GPU powers get harnessed off, because without that GPU boards, you cannot fine tune it. Again, you will be incurring with a lot of server cost, because fine tuning in such a big architecture, right? Such a big architecture takes a lot of time. So these are the general resources. But I will also tell you, don't even stick every time to GPT-3 for every single task. I know it's an amazing, it's outperforming everything. You can test its competitive models as well, which are already open source, right? You can even fine tune GPT-2. Like, just if I am telling you, even there is a question here in the chat box, GPT-2 versus GPT-3, what is the difference in terms of machine learning? It should not be machine learning in terms of architecture, right? So yeah, so there is a difference. Yes, there is a difference. There is a layer wise difference. The amount of billion parameters the GPT-2 was trained is more in GPT-3. But if you go to a very basic level architecture, the tokenizers is same in GPT-2 and GPT-3. The internal BERT attention model is same in GPT-2 and GPT-3. Self-masked attention is already present on GPT-2 and even already present on GPT-3. What is the difference is number of billion parameters and their distribution statistics, right? So start playing with GPT-2. You can easily fine tune GPT-2. Though for that as well, you need a good computational resource. You will need a good server cost and something like this. But yeah, there you can just cost saving from that kind of OpenAI subscription plan. So just there are several available open source LLM models. This LLM is nothing new. There is GPT-2, there is GPT-J, there is GPT Neo X, there is Facebook OPT, there is NVIDIA, recall the name right now. There is Google's itself Plan T5, and Plan T5 right now, recently 2 days back, they had launched, Hugging Face had launched again a modified version of Plan T5. There is Plan T8 that is 10 and that of the Plan T5, and they're telling they're having same level of accuracy with GPT-3, not as good as GPT 3.5, that is the Chat GPT, but at least for GPT-3. And within some days, you will be getting an access for just the thing I was just telling, the that is called just generating context from very large sentences or a large paragraphs or multi-parametric paragraphs. An entire open source architecture is getting launched that is called Hyena. That Hyena will be getting launched within a week at Hugging Face again. Like, so these people are doing an amazing work. So obviously just explore the model hub. I want to do practical and learn BERT architecture for our NLP task. Kindly refer some resources to learn. Okay. So what are your just Ashwin, can you just text here, like what are your specific NLP tasks, so that I can just explain in a very better way. Okay. Any other questions? Difference I had already told. If you guys have any other questions, simple any are. Okay. So here I can see you want to understand the internal architectures of a BERT model. So see, whenever you want to, it might be any task. It might be of text classification, a simple text message for an example, right? So just for an example, you have a text message. For an example, okay, your EMI is rupees 5,000 rupees per month, right? Just for an example, it is your EMI, and you want to extract the EMI amount from this particular text by this kind of a BERT architecture. So what you will do is, so there are multiple ways. I am just telling you the easiest way to do is, if you can do a simple dependency parsing for now. So just generally how a BERT architecture learns from any kind of sentence, right? So generally whenever you pass any kind of sentence to a BERT architecture, so first it might be a labeled or it might be an data, irrespective of their labeling. It will first do a very basic level of dependency parsing. Now the dependency parsing can be done by multiple aspects. It might be a POS tagging, it might be token based tagging, it might be keyword based tagging, it might be vector relationship based tagging, or it might be rule based tagging, it might be phrase based tagging or phrase matcher, right? These are the general possible variations, though people are using multiple other variations as well for doing complex tasks, right? So on a very basic level, the dependency parsing will give you an idea about the structure of the sentence, how the individual nouns, individual verbs, individual operations are interrelated with each other, right? So now you can take, so everything that is being present within a sentence is either a word or a keyword or something called as a token, right? So now what you can do, you can map that particular token to an embedding. So what is an embedding? So on a very basic level, when you speak about an embedding, it's nothing but a bag of vectors. Just my series getting disturbed. Yeah, so when you speak about embeddings are nothing but a bag of vectors, right? So it's speaking from TF-IDF, which is a bag of keywords, to globe, to relational vectors, and something like this. So you have a bag of embeddings, right? So it will generate an embedding for you. So you might use word to vec, you might use any kind of vectorization technique. So generally, commonly the word used to follow the globe, because globe always have a context of that relation mapping. So based on that relation mapping, when an embedding is created, it generates a vector pattern for you. So why I'm just telling it to be a vector, not a scalar dimension, right? Here comes the distance mathematics formulas. So when we speak about, so there is a common difference, like while creating a embedding, what kind of distance metrics you should use. Either you should go with dot, you should go with cosine, you should go with Minkowski distance, you should go with Hamming distance, something like this. It's again very specific based on your task. So just for an example, if you want to store both the dimension as well as the direction of the vector, means my EMI is rupees 5,000 a month, right? So there is a direction in this particular sentence, right? What is the direction? Okay, the amount is my EMI, like who am I, and I am directed to what, that is an amount. There is a directional vector being present. So if you want to store the context of direction, go with cosine. Now, if you want to context, just for an example, you have a complex sentence with multiple facts, and just imagine, just you are plotting that particular sentence in a 3D space. Every sentence is being distributed in that particular 3D space. Here you will go with theoretical distances like Minkowski and something like this. So here again a distance metric is placed. The distance metric specify the position of that particular pattern. That vector embedding is created with that kind of vector pattern, and now that vector pattern is getting learned on that neural network architecture. So now the beauty of BERT is, the BERT is nothing but a bidirectional encoder architecture, right? So this beauty of the BERT is it learns both way of the particular sentences, right? So what was an RNN? RNN is a single way traffic, right? And when you come to the BERT architecture, BERT is a both way traffic. It will learn from both the contexts, from the forward context as well as from the backward context. While speaking about the RNN architecture, if you want to do this, you have to call two layers of LSTMs on it. Like you have to place RNN plus Y LSTMs, right? So this thing is easily being solved by the BERT. I guess you have an idea of it. So this is how generally a BERT works. So, okay, there are two last questions. Can you give me an advice on resources to learn prompt engineering? Yeah, there are many resources. So there itself a book by O'Reilly that is called Beauty of Prompt Engineering. You can read that particular book. You can another book being launched by O'Reilly itself, that is ChatGPT to its full power. That is also can give you an idea about the prompt engineering. Rest, learning prompt engineering is mostly based on understanding the modeling architecture. So without the prompt engineering is always based on, if you have the understanding to the architecture of what kind of model you are calling, you can directly just coming from your sense of it. Okay, is prompt learning some specific type of reinforcement learning, or is there any other kind of a reinforcement algorithm that does improvement? Okay. So you see, when you speak about the reinforcement learning, so see, there is a specific domain of reinforcement learning that is called as the federated learning, like human interfered reinforcement learning, and it is being influenced by the federated learning as well. So federated learning in machine learning industry, federated learning comes from a concept of punishment of the layers, right? So whenever the ChatGPT model, or that is the student model that is being playing on a user end, can't able to perform to its optimal probabilistic threshold, and if the user is flagging or internally it is being flagged as the confusion message or flagged message, it will punish that particular network and it will get retrained on that particular architecture. And again, the internal weight will get updated. The internal DBC is being controlled in such a way, right? So this is the type of the RL being used over there as well. This model learns from a human feedback. So that is called as the forceful learning that we call as over there. That is the very beauty of human-based feedback learning. So there is an automatic feedback loops being set up for all kind of this GPT model. So this is the general type of RL that uses. So the trivial architecture is not so much different with the architecture that GPT-3 used to follow. Okay. Any other question? No, the architecture of the ChatGPT and Q-learning is a little bit different. It doesn't directly have that access to the Q-learning architecture, though they had introduced a different type of a network, not like same like the Q. So they're using a T-shaped network. That T-shaped network follows a series of periodical feature distribution when they pass to that layer. A periodical feature distribution, every time it is not even spheroid, it is sometimes called as an ellipsoid as well. So now the ellipsoid and the periodical feature dimensions are being passed to the internal layer networks, and based on that, it has context dimension, it have dimension to its direction, it have dimension to its position, it have dimension previous occurrence, multiple dimensions, and n-dimensional vector is being designed on that. 3D vector is designed on the backend, and that is being learned on that particular layer. Knowledge domains, how does it decipher that in the given text there are 10 knowledge domains or 5? So yeah, so knowledge domains again, yeah, see. So here if you just have the context of basic NER task, so when we speak about an NER task, like, so in an NER task you can tag any domain, right? No, like this ChatGPT how it defines a knowledge domain. So it actually uses NER at its backend, but that NER is controlled by, see, how a NER works. The NER used to, whenever you are giving a prompt, the individual keywords of that particular prompt is being matched with the existing DB. Whether the embedding is getting matched, or whether the distance metric is getting matched, or not even the embedding as well as the distance metric. People are doing fuzzy matching on the trivial days. People are doing phonetic matching on the trivial days. So that is being rather improved on the later times by embedding matching, right? Because embedding has a relational context to it. Now, if the things are getting matched, they can only tag the domain. So same thing for the Chat GPT as well. They had defined a complete knowledge base at their backend. So, or speaking to be a knowledge base, not to be a good term, it is called as a knowledge graph. So if you have architecture of the knowledge graph, just for an example, knowledge graph is equally available in the right now. So just for an example, you are using YouTube recommendation system. So you are using, suppose you are listening sad song, something like this. So every song is tagged with a genre. Genre is tagged with the mood at the backend. So whatever song you will be searching, your prompt will in that particular format at the backend, and that domain same architecture it works out. Cool. So I guess any other question you guys have? Okay, your last question there is ChatGPT language knowledge generation. Language knowledge generation, yeah, they are these are all the text generator models. So generation is the proper thing, as well as knowledge generation is correct, because they also tell in their own research papers that they used to generate knowledge, but it is from pre-existing database. And if you go to the architecture of the GPT, that is the generated pre-trained transformers, right? So yeah, generation is correct. They are the text writers basically. So you can harness the power at any kind of text generation pipeline. Okay, cool. If you guys have any other query, you can feel free to shoot me in my LinkedIn. I guess you guys have my LinkedIn link. I guess.
Yeah, we have provided your link in the chat section below. Yeah, okay. So Anustup, thanks a lot. On the behalf of the Complete Analytics with their team, I would like to thank you for your time as well and for delivering such a wonderful session. I believe the audience found it insightful, as I really found it insightful on my personal behalf. And hopefully we can conduct more of these sessions with you in future again. And I have provided your LinkedIn profile in the chat section. So any attendee like to connect with him, you guys are free to do it. And hopefully you guys have also filled the feedback poll. I just launched the feedback poll section. If not, I request you all to please fill it in the poll sections, as it helps us to conduct most of these sessions. And also, if any one of you would like to conduct a webinar with us or facing any difficulty in registering to it or connecting with us, you can mail us at datahour@analyticsvidya.com. Also, the recording of this session, and apart from these sessions, all the previous sessions is also available on YouTube channel. The link is in the chat below. Okay. So our upcoming data sessions is tomorrow, day after tomorrow. We have sessions lined up in the line. So all those links are provided in the chat section below. So let's meet you back in the next upcoming data sessions. Till then, see you all. Thank you for joining in. Thanks. Bye bye. Keep learning. Thank you.